Okay, take a second, pause the video, and please write the electron configurations for chromium and copper. When you're ready, resume. So chromium, you should have found 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. And for copper, we would expect that you'd write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Okay, so if you've done that, you've been able to follow the rules, you know what you're doing in terms of electron configurations. The only thing is that you're wrong. Okay, now you say, but I've done everything right, and hopefully you're not too sad about everything. Okay, what is it that's different about chromium and copper? Okay, I'm going to focus on the 4s2, 3d4, and 3d9 sets specifically, and I'm going to draw some orbital boxes for them here. So we'll look at chromium first. We'll look at the 3D set and the 4s, and then we'll look at the same for copper as well. Okay, so I'm going to represent the electrons with the arrows. Alright, so this is 4s2, 3d4. Now, what we found on observation is that that second electron that was in the 4s orbital actually appears more in the 3d set. And we still have the 6 electrons that were there, but they're actually distributed slightly differently. We find that 4s is half filled, 3d is half filled, and this seems to be kind of favorable. So let's see what happens with copper. Okay, rather than having 4s2, 3d9, again, it's that second electron that goes in the 4s set. We actually find that it moves over, essentially, and it appears in the 3d set. It was still 11 electrons between the two orbitals. I haven't added anything, but basically now I'm still seeing this half-filled effect. Now it only applies to the 4s, but guess what? 3d is completely filled. That's also favorable. So what we find for the actual configurations on observation are 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10, and then 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Okay, these are the two exceptions that we'd like you to know to the orbital filling.